Hello, I am Dr. N. Sasikala, Professor in ECE Department of Kamala Institute of Technology and Science, Karimnagar. Thanks to International Research Awards on Nanomaterials and Nanotechnology for giving me this opportunity. Here I want to share my research work on futuristic directions in vision computing and biomechanics. Now, in particular, I have worked on training rolling stock examination, in assistance for the manual rolling stock examination. Now, in India, most of the people, or 80% of the people, they travel from one place to another taking trains. So this trains has to provide a safest journey for all the people. Now, if there is a problem in the bogie of the train, that becomes difficult for their journey. There may be mishaps like accidents may take place, which may risk the lives of all the people. Now, for that reason, I thought of doing the automation for the maintenance of the bogie. Now, in India, these are the two types of bogies that are being used, that is Fiat as well as ICE. Now, many bogie parts are there. The health condition of the bogie parts are very, very important in order that the train doesn't derail or any accident may take place. Now, if you see in India, this is the manual rolling stock examination that are following from years. Now, two people or six people, they sit on the either sides of the train whenever the train rolls into the platform and check for the condition of the bogie parts, whether they are intact or not, whether there is a hanging or not, whether any bolt is loose or not. That it is manually done and it completely prone to errors, because humans may not at times, because of the fatigue, they may not check the problems in the bogie correctly. Now, this may lead to an accident of a train where the lives of many people are at risk. So, in order to avoid this process or maybe to update this process, my thought is to go for automation where the camera can capture this particular bogie condition and the processing is done over those images that are being captured, and we can say whether the bogie part is good or bad. Now, this is the objective of my research work. Now, here the higher end cameras the sensors which are based on the nanotechnology can be used in order to capture the bogie images. The reason for going for the higher end cameras is that you see, normal cameras, they doesn't capture the speeding vehicle. For example, this train, whatever we want the pictures of, this travels at a speed of 30 kilometers per hour, and a normal camera, it becomes difficult for a normal camera to capture. So, cameras which higher end sensors, which has the higher end sensors, can be used for capturing these images. Once these images are being captured, now these images can be processed. Now, this you can see that there is a prototype that is being shown, where you see that on either sides of the train, high speed cameras are installed so that they capture the images. After the capturing of an image, these images from the images of the bogie, the parts of the bogie can be segmented and then they are individually identified, and then we can say whether this part is defective or not depending upon the database. The whole thing is sent to a server which is present at a remote location, where some predicting algorithms will be used, and then these algorithms will tell whether the bogie part is good or bad. And this information can be immediately sent to the maintenance engineer or any other railway personnel, so that they can quickly take the actions if at all there is a defect. And this becomes very easy, and we can save many lives. Now, so you can see here the left side, you can see the live view of a train which is moving, and those are the bogie parts. and see, the train doesn't move only in the daytime, it will be moving in different lighting conditions. So we have taken different lighting conditions for our research, like morning time and afternoon, evening, as well as night. In these all lighting conditions, the camera captures the video of that particular train from where we extract the images, and then the processing is being done. The previous work, if you see, the researchers have done the work related to only few parts of that bogie, like maybe a wheel or maybe a gear system or a brake system, like that. So complete bogie research on the complete parts of the bogie is not being done. Now here it is an interest that work on the all parts of the bogie. So for this, what should be the architecture of the system, or how the computer can learn and identify the bogie parts, this is very important. So first, after capturing the images of the bogie, we have to segment the parts. So all parts are intact in a particular image. We have to separate or segment the bogie parts so that each and every part can be identified. So approximately 29 parts are there in a bogie. All these bogie parts have to be segmented from the original image, and then a database has to be created, or maybe called as a template. A template has to be created, and a library has to be created, so that whenever a new part comes in, new query video comes in, from the query video, the parts is identified against the library that is existing, and the part can be identified first. So before knowing whether the part is defective or not, first of all we have to identify the part. So this is a process called as template creation process, where the image processing is being used on this, and then the object is being identified. For example, in this you can see a binding rod which is being identified. So the segmentation of the part is being done. After the segmentation of the part is done, the complete geometry of the part, we need the complete geometry or shape of the part. So for this, the dilation, the image processing like dilation and erosion is being used on that, and finally the outer border or the segmented part is being seen. So this part becomes the template or a reference like thing, so that whenever a query video comes in, from the query video we extract the images, and from the images the individual part is identified or segmented, and that is compared with the template that is existing. So if there is a match, or what you call it as a correlation between these two parts, then that part will be identified first as it is correct by the machine or the computer, and then it starts identifying the whether the defect is there or not. This is how the process goes on. So this is where the screen shows the different parts of a bogie, like an axle, or maybe the springs, or maybe the center binding rod, or a bolts that are present, or a wheel of the bogie. So these are the different parts, and of course the holding pins are also there. These are the different parts of the bogie. So first, the identification of these parts are very, very important. So two slides are being shown here. One with different lighting conditions. This is at midday that has been taken, and then this is slightly, there is a dull lightning condition, maybe towards the evening and all. And in both the cases you can see that there are boxes that has been shown on the screen, where you see that those are different parts of the bogie that are to be identified. So whenever a train passes by, the train has a movement from either from left to right or right to left. There is a deformation in the parts. Even then the video is being captured, and the image processing algorithms that are used at the back end, they have to identify the parts correctly. Then only we can know whether the part is defective or whether it is in a good condition. The other problem is that whenever there is a shadowing, what you call it as a occlusion, where you see that somewhere the staircase of the compartment comes in front of the bogie, then you see that it is occluded. The bogie parts are being occluded by the ladder or the staircase, whatever that is present. So the camera captures both the staircase as well as the bogie part, which comes as the occlusion. So this, even then, the algorithm or the machine algorithms, the computer vision algorithms, they have to identify the correct part even in the presence of a ladder or a staircase, and then identify the defect also. So this is what the occlusion thing is. And then once the part is being identified, for example, here the holding pin, what you are seeing in pink color, this holding pin has a defect. It has been it has a cut on the one of the sides. So the algorithm identifies the holding pin exactly with all the boundaries and all, then checks for whether this condition, the condition of that particular part is good or bad, depending on the continuity of the segmented part. So you can see that there is a discontinuity in the shape of that particular holding pin, so it identifies it as a defect. Likewise, the research has been done comparing with the previous techniques that are being used in order to identify the parts and all. So the proposed method is very good, and then it is providing very good results, identifying all the bogie parts. Now this is a video where it has been shown what could be the computing time in order to identify the parts, because the computation time plays a key role. Whenever we want to identify, it has to quickly, the machine has to or the computer has to identify very quickly and then send the information to the maintenance engineer or some railway personnel so that they take the action very quickly. Otherwise, few lives are at not few lives, many lives are at danger. So this is a video which shows how all the bogie parts are being identified within less computation time. And what I want to conclude from this research is that automation have to be done in the railways, because the manual type of rolling stock examination, it is very much very much risk, because human beings will not give a correct idea or correct information regarding how the bogie parts are, what is the condition of the bogie parts by seeing the bogie part. It is very difficult. So they are prone to major errors, and to overcome this, we have to design or develop a automated system which can by itself identify the thing, by itself identify the condition of the bogie part, and then send this information within no time to the railway personnel, so that the actions can be taken very quickly and the lives of many people can be saved. So this is what the basic idea of this particular work. And in the future, maybe the system can be extended, the work can be extended for all the weather condition, like a rainy day, or maybe huge snowfall is there. Even in that condition you can identify, and if at all the speed of the train is also more, then also you can identify, and few advanced artificial intelligence systems can be used to make the whole working a better experience. And these are what my references are. And a huge thanks to International Research Awards on Nanomaterials and Nanotechnology for giving me this opportunity.